Hello friends, I welcome you in lecture number 29 on group theory. In this lecture we will discuss this question. This question was asked in GTU Summer 2020 exam. In this question we are given one binary operation denoted by star and it is given on this set n of natural numbers and is given by x star y equal to x raised to y, where this x and y are any two natural numbers. So for any two natural numbers, binary operation star is defined in this way: x star y equal to x to the power y. For example, if I have 3 star 5, then I can compare with this x star y. If I have x star y, I have to take x to the power y. So here it is defined in this way, 3 raised to 5. So we have to show that this operation is neither commutative nor associative, and we are familiar with the definition of commutative and associative binary operation. Suppose we have some binary operation star on some set, say G, then this binary operation star is associative if for any two elements x star y and y star x are equal, and this binary operation star is associative if for any three elements x, y, z we can have x star in the bracket y star z equal to x star y in the bracket and star z. This must be true for any three elements x, y, z in a given set. Now here our set is set of natural numbers, and we first prove that this operation is not commutative on the set of natural numbers. So by the definition, this operation is commutative if x star y equal to y star x for all possible natural numbers in n. If for all xy in this set of natural numbers x star y equal to y star x, then star is commutative. Now if we want to show that star is not commutative, we have to find out particular natural numbers x and y such that these two are different. So we can select any two natural numbers roughly and we can try to search for those natural numbers. For example, suppose I consider 2 and 4 in this set of natural numbers. Then first I find out 2 star 4. If I have x star y, then definition is first element to the power second element. So here first element is 2, second element is 4. So I will have 2 raised to 4, that is 16. And if I find out 4 star 2, then I will have first element 4 to the power second element 2. So this is also 16. So for 2 and 4, this property is satisfied, 2 star 4 equal to 4 star 2. So this will not work. So we consider two other elements. We are interested in those elements for which x star y and y star x are different. So suppose I consider 2 and 3. So we take 2, 3 in this set of natural numbers. Take 2 and 3 in this set of natural numbers. And first we decide what is 2 star 3. This is by the definition of given operation 2 raised to 3, that is 8. And what is 3 star 2? 3 star 2 equal to 3 to the power 2, that is 9. So here we obtain different values. So we can see that 2 star 3 and 3 star 2 are not equal for these two elements 2 and 3 in this set of natural numbers. So we have obtained two natural numbers 2 and 3 such that this property is not satisfied. Therefore we can say that this operation is not commutative. If it is commutative, then we must have x star y equal to y star x for every x and y. But here for x equal to 2 and y equal to 3, we obtain that 2 star 3 and 3 star 2 are not equal. Therefore, star is not commutative on this set of natural numbers. So we have shown that this operation star on the set of natural numbers is not commutative. Now we prove that it is not associative. So we have to search for three elements now, because if our operation is associative, then we must have x star y star z equal to x star y star z for all x, y, z in this set of natural numbers. So we have to search for particular x, y, z for which this property is not satisfied. So that also again we have to search by trial and error. So first we randomly select three elements. We take, suppose x is equal to 1, y equal to say 2 and z equal to say 3. So first we find out x star y star z. X is 1, y is 2, z is 3. Now by definition of given binary operation, 1 star 2 is 1 raised to 2 star 3. 1 raised to 2 is 1. So we have 1 star 3 and 1 star 3 is again 1 raised to 3, that is 1. So here we are using the definition of given operation. We are given that x star y is x to the power y. So here x is 1, y is 2, so we take 1 raised to 2 and square of 1 is 1. Again we are using that definition here also. 1 star 3, that is equal to 1 raised to 3, which is 1. Now we obtain other side and let's see what we obtain. Now we take y and z in the group and we keep x outside. X star y star z. X is 1, y is 2, z is 3. So first we obtain this 2 star 3. By the definition of given binary operation, this is 2 raised to 3. 2 raised to 3 is 8, and then again we apply the definition. 1 star 8 equal to 1 raised to 8, which is 1. So here also we obtain 1. So this choice will not work. So I have to change my elements. Suppose instead of 1, I consider say some another element, suppose 5. So let me take, instead of x, I am taking 5 here. So I have 5 star 2 star 3. 5 star 2 will be 5 raised to 2 by the definition. 5 raised to 2 is 25, so here we write 25, and this is going to be 25 raised to 3, 25 to the power 3. 25 star 3, that is equal to 25 to the power 3, and we check for this. Now we have changed only value of x, which is 5 instead of 1. So here we replace 1 by 5. Here also we replace 1 by 5. Same thing here, 5 star 8, and here we have 5 raised to 8. So now we can use scientific calculator, or this we can rewrite as 5 square to the power 4. So 5 square means 25 to the power 4, and here we obtain 25 to the power 3. So we can see both are different. So in this way we find out 3 elements. Therefore for these 3 elements we see that x star y star z is not equal to x star y star z for x equal to 5, y equal to 2, z equal to 3 in this set of natural numbers n. Therefore, this operation star is not an associative operation, is not associative on this set of natural numbers. So in this way you can decide particular elements. You don't have to cram all these elements. You just start by trial and error, and if you are not getting inequality, you can change your choice. And here it is sure that this operation is neither commutative nor associative, because you are asked to show that this is neither commutative nor associative. That means you are given that this operation is not commutative and it is not associative, but you have to prove that. So whenever you have this type of question, answer is already given. You just have to prove that that statement is true. So here first we have taken two elements for showing that operation is not commutative, and we have 2 and 3. So we have shown that 2 star 3 and 3 star 2 are not equal for these two natural numbers. Therefore this is not commutative. And here we obtain inequality for x equal to 5, y equal to 2 and z equal to 3. So in this way you can easily check or prove that given operation is either commutative or associative, or it is neither commutative nor associative. So this is all about this session. I hope you like it. Thank you very much.